The mean temperature for Knoxville, Tennessee in the month of January between 1872 and 2015 was 38.6 degrees Fahrenheit, but the distribution is unknown. Assume the standard deviation is 10 degrees Fahrenheit. We take a sample of n equals 36 and find the following probability. We want to find the probability of the fact that the x means are less than 40 degrees. In this problem, we'll have to first calculate the z-score. Since we're dealing with a sample means, we're going to have to use what's called the central limit theorem. The central limit theorem states that the mean of the means is the same as the mean given. And the mean given is the fact that it was 38.6. So we can say the mean is 38.6. Now the standard deviation we need to change. So the standard deviation of those sample means is going to be the population standard deviation divided by the square root of our sample size n. So in this problem, our standard deviation is 10, and we have a sample of 36 divided by square root of 36. So on our calculator, we take, move it up a little bit here. Okay, on our calculator, we're going to take 10 divided by the square root of 36 and hit enter. So we see that number is 1.66667. Let's write that down. So 1.6666667. There we go. So we're going to have to use this new standard deviation in our problem. That means on our curve, we're going to also have to change it. So as far as our distribution for our sample means, the mean is still going to be 38.6, but we're going to have to add 1.67 each time to it. So we're going to have to adjust that. The next one would be 40.3, and the next one would be 41.9. And then we would have to subtract 1.7 from each one of those. That would be 36.9, and then 35.3. There we go. And then we want to find the probability that the sample means are less than 40. So go ahead and mark that on here. That's where the sample mean is 40 and less than 40. So we're finding the area of that region, and that will be the area of our probability. Remember, what we have to do next is convert it to a z-score. So to convert it to a z-score, we're going to have to use our formula. Remember, our z formula is going to be z equals x minus the mean over the standard deviation. Now remember, since we've used the central limit theorem, our mean stays the same, which is 38.6, but our standard deviation now has changed. So in this problem, the x score is 40 minus our mean, which is still 38.6. But now we're going to divide it by our new standard deviation, which is 1.666667. And let's go ahead and get that on the calculator. So we take 40 minus 38.6 and divide it by 1 point, and let me write a few sixes out here and hit enter. So our new z-score is 0.84. So the probability that the sample means are less than 40 is the same as the probability of z being less than 0.84. Remember, if we put it to our standard normal, now we can use StatCrunch. So let me go ahead and label this curve here with our standard normal mean being 0 and our standard deviation being 1. 0.84, we can see that it lines up nicely, so it matches the other one. 0 equals, it should be positive, sorry about that, positive 0.84. And again, we're shading to the left since it is less than, and we're going to try and figure out that area. StatCrunch does this so nicely for us. So on StatCrunch, we're going to go Stat, Calculators, and we're going to choose the normal one. On our normal calculator with our mean of 0 and standard deviation of 1, since we're using z's. And now we're going to choose that it's less than, and we're going to type in 0.84. So x is less than, which is really z, since mean is 0, standard deviation is 1, is 0.84. Hit compute, and we calculate the probability. So our probability is going to be 0.7995 if we round it to 4 decimal places. Remember, that's the area that is in the shaded region, 0.7995. Make sure we label that 0.7995. So that Z region is the same as that X bar region. So our statement's going to be a little bit different this time. Now, instead of saying if one person is randomly selected, we can say if one temperature, if 36, because our sample size is 36, if 36 temperatures are randomly selected, the probability that the mean temperature in January in Knoxville, Tennessee is less than 40 degrees Fahrenheit is approximately 0.7995 or 79.95%.